Welcome to EFI Basics Part 8. In this video, we're going to be discussing the different types of ignition systems, ignition coils, and finally, ignition coil dwell. We have a lot to learn, so let's get started. So let's begin this video by looking at the different types of ignition systems that we're going to find in EFI tuning. Now, we're going to see three different styles or types. We're first going to see a distributed spark ignition system. We're also going to see a wasted spark ignition system. And finally, the most common on modern engines, a direct fire or sequential style ignition system. Now let's look at the distributed system and see what it's all about. Now, in a distributed spark system, we're going to have a distributor. Now, the distributor is going to be connected to our engine, typically on the camshaft, and the distributor is going to spin in relation to our engine. So we're going to have a gear mechanism that's going to, somehow mesh or attach itself to the engine to spin with the engine rotation, and that gear is going to attach to a shaft on the distributor, and that shaft is going to connect to a rotor. Now the rotor is going to spin as the engine spins. And we're going to finally have a distributor cap that's going to mount on top of the rotor, and it's going to have points on the distributor cap. And we're going to have spark plug wires that connect to those points, and those spark plug wires are going to connect to our spark plugs on our individual cylinders. Now, depending on how many cylinders we have, there's going to be that many points on our distributor cap. So if we have a 4-cylinder engine, we're going to have 4 points on our distributor cap. If we have an 8-cylinder engine, we're going to have 8 points on our distributor cap. Now, the orientation of the spark plug wires to the distributor cap will matter, because there's going to be that physical or mechanical link that we're going to have to take into account. As our rotor spins, it's going to be firing in the firing order of the engine, and it's going to be spinning and sending the spark from our ignition coil through the distributor cap, and the rotor is going to basically transfer that spark energy to the correct point, to the correct cylinder to fire the spark plug when we are telling it to. So if we mix up the plug wires on the distributor cap, we're going to have the engine out of firing order. Likewise, if we install the rotor on the distributor wrong, we're going to be firing at the wrong point on our distributor cap and having the same effect. Now, distributed spark ignition systems are inherently a little less precise when we're going to compare them to the other ignition systems we're going to look at here in a second. And this is because we have that mechanical aspect. So we're going to have that gear and the shaft and the rotor, and there might be a little bit of slop or play or misalignment, and that might transfer into a little less ignition precision. So if we say command 30 degrees out of our ECU, we might not see exactly 30 degrees, and we might see 29 or we might see 32. So there's going to be a touch less accuracy using a distributed spark system. Now, the other disadvantage is going to be that our ignition coil is going to have much less cooling time, because we're going to be firing and discharging our ignition coil in the system to provide spark to all the cylinders that have to fire off our distributor cap. So in comparison to our other ignition systems we're going to look at, the distributed spark will have the least reliability as far as our coil is concerned, because the coil is going to get much hotter because it has to constantly fire and discharge and fire and discharge. Also, we're going to be able to provide less spark energy in this style system, because again, we're going to have less time to charge the coil and build the peak energy out of it. Now, the next style ignition system we're going to talk about here is the wasted spark ignition. Now, this is going to be when we have 2 ignition coils that are going to be tied to one output from our ECU. So our ECU is going to trigger the ignition coil when we want it to fire. And in this case, again, we're going to have 2 ignition coils triggered to one ignition output from the ECU. Now, this is similar to the idea of a semi-sequential fuel injection, where we have two injectors wired to one output on the ECU. We're going to be firing our one coil when we want. So it's going to fire on our compression stroke, but the other coil is going to fire on the exhaust stroke. And that's where this name wasted spark comes from, because we're going to be wasting the spark, and it's going to happen on the exhaust stroke. Now, Looking at our wasted spark, we're going to be firing and discharging and firing or discharging our coil, and that's going to happen twice per engine cycle. Now this is going to inherently make the wasted spark a bit more reliable because we're going to be charging and discharging our coils much less than we would in a distributed spark system. Also, there is a slight advantage on a wasted spark system where we might see a touch difference in power if we run very, very rich air fuel mixtures. Because at a very rich air fuel mixture, we might not combust all of that fuel that was in our combustion stroke, and it's going to carry through into the exhaust stroke. If we fire off the spark plug in our exhaust stroke, we might be able to burn some of that residual rich mixture off, and it might clear out the cylinder just a bit before our intake stroke. So it might give us a bit of power because we're giving that slight edge of burning off whatever's left. If we're running a very rich air fuel mixture, in most cases this is not going to really play a factor, but it is something that can occur and something that should be noted. So the last ignition system that we're going to find, and it's going to be the most common, is the direct fire sequential ignition system. Now this is going to be found on most all modern engines, and this is done for several reasons. Now the first thing we need to know is that there's going to be one coil per cylinder, so we're going to fire one coil every auto cycle, and by doing this is going to give the maximum charging time for our coils, which is going to make sure that the coil doesn't get as hot as with distributed and wasted spark, and also going to provide the maximum charge time for our coil. So we're going to get the most spark energy in a direct fire style ignition system. Now, the other big benefit to running the direct fire system is that we're going to be able to individually tune the spark in our cylinders. Because we're firing only once per cycle, it's going to give us that ability to go in and, if we want to advance or retard the spark on, a cylinder for whatever reason, if we see, that particular cylinder is knocking, and we can see it on our knock sensor, we can go in and actually detune the area where it's knocking and let the other cylinders run the spark advanced from our main spark table. So this is going to be an advantage, especially when we start really looking at the tuning process. The direct fire is going to be what you want to always run. One last thing that's worth mentioning is that the sequential style ignition systems typically are going to be coil on plug, and we're going to see that the coil is actually mounted on top of our spark plug. But on some engines, we're going to have a coil near plug, and that simply means that our ignition coil is going to be mounted not on top of our spark plug. So we're going to have our coil mounted on a bracket that's going to have a spark plug wire similar to our distributed spark, but in this case it's going to have our spark plug wire that's going to go to our spark plug. This is going to be probably the most commonly found on the Chevy LS series of engines. So the engines you're going to see in the Corvettes and the Camaros, they're going to have this coil near plug setup, and that's because we can't run a coil right on top of the exhaust manifold that's located right next to the spark plug. So in these systems, you're going to see this style coil near plug, and it's a bit unique, but since the LS engine is very common, and especially in the performance industry and the performance applications, it's something that you're going to probably see as a tuner. So to recognize this, it's still a direct fire sequential system. It's just that it's mounting the coil not on top of the spark plug, and it's going to have a spark plug wire. So in this next part of the video, I want to talk about ignition coils. Now, ignition coils are a relatively simple device, but to better illustrate it, let's check out an internal diagram of what we're going to find inside of a coil so we can better illustrate the concept and what's going on. Now, looking at our coil, and this is going to be a generic diagram, but looking at what would be found inside of a coil, we're going to see that we have both a primary and a secondary winding. And it's going to have an iron core that's going to separate both of these windings so they don't touch each other. Now our coil is going to have a 12-volt power supply, and it's also going to have a means of switching or grounding the coil to start energizing it. Now this is going to be using a transistor or igniter, which we're going to talk about in a second. But Going back here to our primary and secondary windings, we're going to see that they have they're wound, essentially wire inside the coil. Now our primary winding is going to have less turns than our secondary winding, and it's going to be a much thicker wire used. And if we look at our secondary winding, we can see it has a lot more windings, but the wire used is going to be much thinner. Now, our primary coil is going to carry a high amperage, usually about 7 amps, but it's going to carry a low voltage. Our secondary coil is going to carry a high voltage, but low amperage. So typically it's going to carry like around 30 to 35,000 volts, but it's going to carry less than 1 amp. One side of our coil is going to be connected to our 12 volt, and the other side is going to be grounded through the transistor that we just spoke about. The switching transistor, or the igniter, is going to be used to turn on the coil. So it's going to be used to charge the coil and then discharge the coil. So essentially it's going to be acting like as a switch, and it's specifically a switch to ground per se. So it's going to give the coil the ability to ground the circuit in order for the primary windings to energize. Now, on some newer engines, we're going to see that the igniter or the transistor is built into the coil itself. Some older engines, you might have an external igniter or transistor module that's separate from the actual coil. Now, the ECU is going to tell the igniter when to turn on and charge and when to discharge the coil. When the igniter is turned on, the primary windings are going to be energized. When the igniter is turned off, the magnetic field collapses around both coils and the energy is transferred into the secondary winding. The high voltage, low amperage, is then transferred into our spark plug to initiate our combustion or spark event. And we're going to see anywhere from 30 to 35,000 volts transferred into our spark plug, which we're going to need because we're going to have to pierce that cylinder pressure to get our combustion event to occur. So in this last part of the video, I want to talk about ignition coil dwell. Now the coil dwell is simply going to be the amount of time that the ECU is going to hold the igniter in a charged or on state so that our primary windings can charge up to that 7 amp point to release to the secondary windings to provide the maximum amount of spark energy to our spark plug. Now, we don't want to confuse coil dwell with our spark timing. The ECU will still calculate the spark timing event based on when it releases the igniter to release that 7 amp point to our secondary windings to fire our spark plug. So the coil dwell can be thought of similar to the latency or offset or dead time in our fuel injector characterization that we talked about in the previous video. We know with the injector, when we command the injector to turn on, it's not going to immediately deliver fuel. So that offset is going to tell the injector or the ECU the total effective pulse width that it needs to account for to deliver the proper fuel mass into the engine. And the coil dwell is going to be that same idea. It's going to turn the igniter on, and the point where it releases the signal to the igniter is the point where we're going to fire our spark plug from our spark timing map. The coil dwell is just going to provide how long we need the igniter to stay in a on status to allow the primary windings to charge up to get that spark energy. Now, looking at dwell, increasing our coil dwell has the potential to increase the spark energy because the longer the dwell, the longer our primary windings have to charge up to that maximum point of 5 to 7 amps. Now, depending on the coil design, the amount of time or the amount of coil dwell required to reach that point is going to vary. Now, if we have a coil that takes 2 milliseconds of coil dwell time to allow the primary windings to reach maximum charge and then discharge to reach the maximum spark energy, if we increased to 3 milliseconds of coil dwell, we're not going to see any further spark energy increase. We're just going to be increasing the amount of heat that the coil is going to retain because we're keeping it in that charging or the on state. So that 1 millisecond extra coil dwell that we could program will not do anything other than make the coil prematurely fail over time. Now, another thing to keep in mind with coil dwell is that it's going to vary based on engine RPM as well as battery voltage. So if we have our charging system or our battery goes down to 8 volts, it's going to take longer for the primary windings to charge in order to reach that 5 to 7 amp saturation point. So it might take an extra 2 milliseconds of coil dwell at a very low battery voltage. But if we go up to something like 16 volts in our charging system, if it could theoretically get that high, it would take much less time for the coil, for the primary windings to reach that saturation point. So we might reduce our coil dwell, from 2 milliseconds, we might reduce it down to 1.5 milliseconds to get the same spark energy and the same point of the primary winding saturation to occur. So the coil dwell is going to vary based on battery voltage. So at lower voltages, we're going to need more coil dwell. At higher voltages, we're going to need less coil dwell. In the same manner, if we look at engine RPM and we look at how long it takes to complete the auto cycle, we know at lower engine RPM levels, such as 1,000 RPM, we have a 120 millisecond window to complete that 720 degrees of rotation of our auto cycle. And then at 9,000 RPM, we have 13.3 milliseconds, so there's a much smaller period of time. That means that we have much less time to charge and discharge our coil. And that's the same idea as injector duty cycle, where the available time shrinks with engine RPM. And it's going to be the same case with our coil dwell. We're going to have less time that we're going to be able to charge and discharge our coils. So we're going to be less time or less coil dwell as our engine RPM increases, so that we don't overheat our coil. The last thing to kind of touch on here with programming coil dwell is that some systems will only allow a singular coil dwell value to be programmed. So, we're going to have basically a one-size-fits-all coil dwell. And while others will allow that 3D table to be programmed that I kind of talked about with battery voltage and engine RPM. And this is going to give us the greatest flexibility for both coil longevity. So we're going to have the least heat built up. And it's also going to give us the ability to provide the maximum spark energy because we're going to be able to vary that coil dwell to achieve that saturation occurring on our primary windings to get the maximum voltage. So just note that in the future, when we're doing our system-specific videos, we're going to be talking a little bit more about coil dwell and looking at it and how to program it and what we can program. And some systems are going to be limited, and some systems are going to have a lot of flexibility and ability to program and control the dwell very precisely and in our inductive style ignition systems.